In this video, we'll discuss a challenge question from IBHL test paper. Rational function graph is given to us. We need to find its equation and then graph reciprocal absolute value of the same. We'll understand this strategy to solve such questions with a similar example. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this playlist, we are taking many questions from IBHL exams. All these questions are based on functions. So it is exam practice. These questions have come many times in past test papers, and therefore we need to understand the correct strategy to solve them efficiently. The question which we will consider is the graph of y equals to a plus x over b plus cx is given, which is on the right hand side. Find the value of the constants a, b and c, and part b is using the values of a, b and c calculated in part a, sketch the graph of y equals to b plus cx over a plus x absolute value. A very beautiful question which has come a couple of times recently, and therefore how do we solve this question is very important for all those who are taking IB higher level mathematics. Right. So let us see how do we do it. First, let us try to understand the question itself. We are given graph of a rational function which is a plus x over b plus cx, which is right there, right? We need to find the values of a, b and c. Perfect. But later, do you see the function absolute value? It is actually a reciprocal of this function, right? So, let us say if f of x is given to us as a plus x over b plus cx, then in part b we have to find g of x, which is basically 1 over f of x, right? And not only that, absolute value of that. That is the question. So the graph is given to us. We can actually sketch reciprocal from the graph itself and also find its absolute value. Do you understand that part? Correct? So that is to be appreciated, right? Well, now let's actually begin to answer the question part A to find A, B and C.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
So here is the figure given to us, and we clearly see that we have x-intercept at minus 2, 0, y-intercept at 0, minus 2, vertical asymptote is x equals to 2 and horizontal asymptote is y equals to 2. So with these informations, we can easily write down our rational function, correct? So if horizontal asymptote is at 2, that means this ratio has to be 2 over 1, right? So we can say y equals to 2 over 1, that is one part. This we get from the horizontal asymptote, and then we have the x-intercept at minus 2. That means this part, one factor, should be 0 in the numerator when x is minus 2. And that is possible only if we have x plus 2 in the numerator, correct? So x plus 2 in the numerator will ensure that there is an x-intercept at minus 2. Make sense? Now, how about the vertical asymptote of x equals to 2? Well, for vertical asymptote at x plus 2, denominator should be 0, right? Add 2, that means in denominator we have x minus 2. Then substituting 2, we will get a 0. So we kind of get our equation. Do you see that? So how did we find it? We went for the horizontal asymptote, right? And got a factor which could help us give the ratio of numerator and denominator, leading coefficients. Then we looked into the zeros, which gave us the factor in the numerator. Vertical asymptote gave us the factor in the denominator. Perfect. So now this matches with the given graph. Now, how do we exactly match the graph? Well, to check our answer, let's check with y-intercept. Y-intercept is a point left to check, which is 0 minus 2. So if I substitute 0 for x, what do I get? If x equals to 0, in that case, we do get y equals to 2 over 1, which is like, okay, 0 plus 2 over 0 minus 2. Well, we do get minus 2. So that's a good checkpoint. You get the idea. Therefore, the equation which we have got is perfect. And we can say now that our function is y equals to 2 times x plus 2 over x minus 2. Make sense? Do you see how we got the equation, right? Now let's take it to the next page. So we have the equation as y equals to 2 times. When is this x-intercept? Minus 2 means x plus 2 is a factor in the numerator. Vertical asymptote at x plus 2 means x minus 2 is the factor. Now, it is important to see that the equation given to you is a plus x over b plus cx. So I cannot multiply by 2 here. You get the idea. So what I need to do? Well, I need to divide both numerator and denominator by 2. So in that case, I get x plus 2 over half x minus 1. Correct? That's all we get. So when you rearrange, you might get like this. And that will give you the values of a, b, and c, right? So this gives you, or you can rewrite again as 2 plus x, just to match exactly what it is, minus 1 plus half x. You can say a is equal to 2, b is equal to minus 1, and c is equal to half, correct? Right? However, writing the equation in this term is kind of odd, right? We prefer to write as it was earlier. So to do the next part, where we are maintaining same a, b, c, d, but we are finding the reciprocal of this equation, I will rewrite this equation, correct? So I'll rewrite this equation as y equals to 2x plus 4 over x minus 2. Does make sense, right? We have answered part A, but now we are going to answer part B, which is right there, right? We have to graph the equation which is the reciprocal of that, right? So we have 2x plus 4 and x minus 2, the question was to, using the values of a, b, c, d, calculate in part A, sketch the graph of b plus cx over a plus cx. Means reciprocal, right? So let's try to graph the reciprocal, which is y equals to x minus 2 over 2x plus 4. Makes sense? We actually want absolute value of this. But first, we will graph the rational function and then the absolute value, correct? So let us see, how do we do the rational function, which is x minus 2 over 2x plus 4? Well, again, x minus 2 means x-intercept at 2, right? 2x plus 4 means y vertical asymptote at x minus 2, right? So at minus 2 we have vertical asymptote. That is where 2x plus 4 equals to 0, right? So x is equals to minus 4 by 2, which is minus 2, correct? Now, the y-intercept will be when x is 0. So when x is 0, the y-intercept is, let me write down, y-intercept will be when x is 0, which is at minus 2 by 4, which is equal to minus half. So minus half is right there, y-intercept. Horizontal asymptote is at 1 over 2, right? Let's write down. Horizontal asymptote is y equals to half, correct? So that is horizontal asymptote. So let's draw the horizontal asymptote. And we'll sketch the graph now. Since we know that these are the intercepts, x and y, we'll connect these points, right? And the other side will be kind of like this. So we got the graph of inside function, and now we want to draw the graph for absolute value. So absolute value means always positive. So the negative part will now get reflected, right? So from this point itself, the graph gets reflected. Minus half becomes plus half, and the vertical asymptote, when you are approaching from minus 2 from the right hand side, it was going minus infinity, but now it will move towards positive infinity. So it will go like this. Do you see that? So let me redo it. It will be, because I have to connect with this point, right? And the right side will be same, because it is always positive, like this, and the left side will match. So this graph will be of absolute value. Y equals to absolute value of x minus 2 over 2x plus 1. Do you see that? That is how you're going to sketch this particular graph. Make sense, right? So I hope these steps are absolutely clear to you. Let us look at the summary of this particular question. We were given the equation, which is right there shown to you, the graph. From the graph, we found the function, which was 2x plus 4 over x minus 2. And then we sketched the reciprocal of this function. Let's call this function as 1 over f of x now. So reciprocal, how did you sketch? The zeros becomes the vertical asymptote, right? That 0 becomes the vertical asymptote. And after that, we made the absolute value function, which is 1 over f of x absolute value, by converting all negative portions as positive, getting the blue graph, right? So that is how we really sketched it.